What's going on, everybody? This is Mr. Diamond, and this is a little bit of an extra for your Friday. This is just a video of me going through an extra example to kind of practice basically all of the concepts that we've talked about here. Our goal here is going to be to take this structure. We're going to turn it from Lewis structure to skeletal. And then from there, we want to know the geometries and the hybridizations, as well as sigma and pi bonds. So it's really going to be like a big review of basically everything. And we only care about geometry and hybridization of A, B, C, D, and E here. So first thing, Lewis to skeletal. We're going to go through and we're going to start with our carbons. So I'm going to start over here. It's usually best to start on kind of one side. So I'm going to do my first one. Then there's double bond, single bond, double bond. And don't worry if your hexagons aren't as good as mine. You'll get used to it after doing this for a lot. Then this carbon down here comes down and then comes up, down, up, down. This one is double bonded to an oxygen, bonded to a nitrogen. That nitrogen is bonded to two H's. Now you notice this isn't connected. That is actually okay. That is totally okay if that happens. Or you can reconnect it like that. That is also equally fine. So I assume this was the easiest part. I guess I didn't give the warning to pause this if you want to try to work them out ahead of time. But pause it if you want to work this out ahead of time. But that was going from Lewis to a skeletal. So Lewis to skeletal, check. Now we need the geometry, hybridization, sigma, and pi bond. First, we're going to do sigma and pi bonds because it's actually easier to figure that out. Make sure I got my little hat on there. It's actually easier to figure this out from this up here. So what I like to do, the method and technique I like to do if you're having trouble counting it, is actually to go through and put a little tick mark every time you've counted one, preferably with two different colors. So I'm going to mark all of my sigmas with my pencil and all of my pi's with my purple pen here. So we're going to go through and we got 1, 2, 3, 4, 5. The first one of every double bond. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Broke all the way at the end there. And 22. So we've got 22 sigma bonds. And then I'm going to take my purple and we've got 1, 2, 3, 4 pi bonds in this whole structure. Done with that. Okay, geometry and hybridization. So let's go ahead and I'm going to make some space down here. We've got A, B, C, D, and E. Let's get this so it's a little more centered. Starting with A, we're looking at the hydrogen. So geometry. And we're going to have hybridization. Hydrogen is only bonded to one thing. One thing bonded to another thing can only be linear. It can only be a straight line. And hydrogen does not hybridize. It is in A. That's really ugly. Let's rewrite that. Not applicable in A. Hydrogen will not hybridize. Okay, what about B? Well, it's attached to 3 total steric groups. So we're looking at a trigonal planar. And then hybridization, we've got S, SP, and then SP2. So it'd be SP2 hybridized because it's attached to 3 groups. For C, we've got a carbon attached to 4 groups. We know that is tetrahedral. And then that's going to be SP3 hybridized because that's a total of an invisible 1 and then a 3 there. So that's 4 total. It's bonded to 4 things. So it's SP3. For D, it's bonded to 3 total things, just like this carbon over here. Even though this one is an O, that one is still going to be a carbon. Actually, we're going to make this a little bit more complicated. I know you've probably already labeled this, but past Ian is sorry. We're going to make this about this oxygen instead. So that oxygen is a linear geometry. It is only bonded to one thing that is an actual like physical bond, but it's still going to be sp2 hybridized because it's got those lone pairs. I don't think it did an example like this, so I apologize for switching it up, but I think it's better for you if I do an example like this, or I bring up an example like this in the worksheet time. Okay, and then finally, I know this looks like neon, but this is actually nitrogen. Nitrogen is bonded to 1, 2, 3, 4 things, so that is one of which is a lone pair here. So because that's a lone pair, this would actually be trigonal pyramidal. But we have an exception to our rule, and our exception to our rule for hybridization is if there is a lone pair next to a double bond. And we have that. We have a lone pair that's connected to a carbon that's in a double bond with something else. And if that's the case, that means it is not going to be sp3 hybridized. It's actually going to be sp2 hybridized. That also technically means, and I don't think I brought this up explicitly in the other one, so hopefully you've watched this video or I've mentioned this in class. Otherwise, I'm very sorry. But this is not actually going to be trigonal pyramidal. If you go back to that example problem that we did, or that little example that was in the notes, you'll have seen that it actually flattened out, which means it's actually trigonal planar in this example. Even though that goes against what all the rules we've talked about, this is that exception, so it'll actually be sp2 hybridized, and it'll be trigonal planar. So all our geometries, our hybridizations, sigma pi bond, and a skeletal structure. I am exhausted. That's why I am yawning. It's a long question, but it covered basically everything in the chapter. As long as you can do this, if you can know all of these steps that are in here, if you know what is hybridization, and be sure you can explain it, and then what is sigma versus pi bonds, and be able to explain it, you're pretty much good. That's I would say 80-ish% of the test. We'll call it like 84% just because I'm feeling like that's the number we're going to go with. So 84% of the test is just this stuff right here. What is hybridization? Can you explain it? What are sigma and pi bonds? Can you explain it? And being able to take and do all of this kind of stuff. Lewis to skeletal. Technically, skeletal to Lewis will probably be on there, but that one's less important. Figuring out geometries, figuring out hybridizations, figuring out sigma and pi bonds. I hope that helps. I hope you guys have a great long weekend. By the time you're watching this, I will hopefully be in Pennsylvania and hopefully not arrested for trespassing on a super cool abandoned coal-burning town. If you're in the future and watching this, then that statement will make no sense. And I guess just ask me about it in class. Have a great rest of your day, everybody. Hope to hear you soon. I will see you guys again after this long weekend.